So, ladies and gentlemen, if you did yesterday's stuff and you're like, man, this isn't too bad, well, this is very, very similar. This is chapter 7.2, multiplying, dividing rational expressions. You guys have seen this already in Algebra 1. This is, again, the second time you've seen it. Okay, and that's our goals for today. Multiply and divide these rational expressions. We're going to simplify. Okay, so here we go. As we're multiplying rational expressions, step one, can we factor? Okay, we're going to completely factor numerators and denominators if we can. Okay, if they're monomials like what we have on example 1 and 2, or 1a, 1b, well, we can't factor those. Okay. Step number 2, we're going to multiply numerators and multiply denominators, and then simplify. Now, step 2 and 3 are interchangeable. You could reduce and then multiply, or you can multiply and then reduce. It's kind of whatever you want to do. I'll kind of show you both ways, and then you guys decide on how we want to proceed or what you like the best. Okay?
Mr. Gotch?
Yes?
It got grainy.
It's grainy? You can focus. Is that any better? Is that okay?
No, it's still super grainy.
Is it grainy for anybody else? Might just be your internet. Hunter, give me a thumb. No, it's not. Okay, so it might be your internet. So I am recording this, so just in case you're having issues. Okay, maybe close up some of your tabs if you got a bunch of tabs. All right, here we go, ladies and gentlemen. So one way we can do, this is monomials here, I'm multiplying. One thing you guys can do is you can multiply all the tops together. 5 times 3 is 15. X to the 4th times x, we add those exponents, that's x to the 5th. This is, again, one technique. We can multiply across. 2 times 12 is 24. X squared, x cubed is x to the 5th. Okay, adding exponents. Well, now we can look to reduce these. So again, we are multiplying these fractions. You multiply the tops and bottoms. Now we look to reduce 15 and 24. What do those guys have in common? What are they both reducible by? What can we reduce by? Give me fingers. Use your chat. Hopefully we can see this now. Jose, Greg, what do you guys see? What can we reduce by? 3. Very good. So 15 and 24 reduced by 3. So that leaves me with 5 on top. And 24 divided by 3 is 8. Okay, so we end up with 5/8. And then the x to the 5th over x to the 5th completely reduce. So I got nothing left. So final answer is just 5/8. Thought we might have some x's there. So final answer just 5/8. Okay. So that's one technique, is you multiply across and then reduce. The other option, I got example B here, so I'll read these off. I have 4x to the 3rd y over 3x y to the 4th, and then times 6x squared y squared over 10x to the 4th. So the other option that we can do is we can look to start reducing first and then multiply. Okay, some people like to do that. All right, so let's take a look at how that would be done. All right, so basically anything on top can reduce anything on the bottom. We have all monomials here, so we can do that. So I take a look. I've got a 4 and a 10. I know those are reducible by 2. So reduce that by 2. Okay. I've got an x cubed and an x to the 4th. So the x to the 3rd reduces the x to the 4th. So I have 1x now on the bottom. Okay. So far, so good. And what else do you see? Let's see. I've got a y. I'm going to reduce this y to the 4th by y to the 3rd. I've got a 6 and a 3. I can reduce that. So 6 divided by 3 reduces, that gives me 2, and that cancels. I've got some x's on the bottom, and I have an x squared on top. So this x and this x reduces these two x's. So those guys are gone. And then finally, I've got y squared, y cubed. I got y squared reduces that to a y. So I look to see what I'm left on top, and I multiply. I've got a 2 and a 2. So multiply, that's 4. And on the bottom, I've got a 5 and a y. So that's 5 times y or 5y. Okay. So there's this, again, two different ways to look at this. Okay. I think this is a lot messier. Okay. So, and it's, you know, again, you're going to lose stuff from time to time. Kind of like this method more, where you multiply across and then reduce versus reducing and then multiplying. It's kind of your choice on what you like best. Okay. But before you circle the final answer, make sure you have reduced everything. You don't have anything else in common. Okay, so I've shown you the two ways. I think I like this way a lot better. Okay, example 1A. Okay, so that's how I'm going to do the last one. Just real quick. So again, we're going to multiply across. So I'll show you that one more time. If I'm going too fast, let me know. I've got 10 times 6, that's 60. I have x squared x cubed, that's x to the 5th using addition of exponents. I've got a y and a w to the 5th. All right, so I got 3 times 20 is 60. X times x is x squared. Y times that y is y squared. And then I have a w to the 3rd left. Okay, so I went through and I multiplied. So not too bad. And now I look to reduce. Okay, I wouldn't want to leave this whole thing. I can reduce the 60s. Boom, karate chop. And let's look at your x's now. I have x to the 5th over x squared. So if you need to, write out your 5x's on top and your 2 and then reduce. But I just subtract 5 minus 2, and that leaves me with x to the 3rd. On top, I've got one y, and I got two y's down here, so yy, or y squared. So this guy reduces this one, leaves me with a y. And then last but not least, guys, I got w to the 5th, w cubed, again, 5 minus 3, that reduces to w squared. So final answer, I have x cubed, w squared all over y. Any questions, y'all? So far, so good. Give me a thumb on where we're at with this. Give me a thumb. If you guys don't have your camera on, you guys can use your chat. It says yes, no, go faster. If you go to more, there's a thumbs up little icon. So yes, no, go slower, go faster. Thumbs up, thumbs up, thumbs up. Thanks for the thumbs up. No thumbs down, no questions. Riley, hopefully it's clear for you now. All right, so let's move on. If you guys got no thumbs down, it means you know what you're doing. All right. So we take a look at number 2. Now we start seeing some monomials turn into binomials and trinomials here. Okay, so hopefully that's nice and clear for you guys. Let me try to zoom in just a touch more for you guys here. All right, so example 2A, I have a x divided by 5x squared minus 20x, and then times the next fraction, I've got x minus 4, and then divided by 2x squared plus x minus 3, okay? So I'll do this first fraction here in black, and I see some factors I can do on the bottom. Okay, so we look to factor. And 5x squared minus 20x. What can you guys factor here? Madeline, what do you see? Jasmine, what do you guys see? What can I take out? 5x squared minus 20x. What's the GCF of 5x squared minus 20x? What are they all divisible by? Use your microphone. Jasmine says 5, and you can take out a little bit more. 5, and they each have an x there too. So 5x, very good. Very good, Jasmine. Jasmine, use exclamation points. You're like confident. It's 5x, Mr. Gotch. Yes. Jazzy, you're awesome. All right, so divide by 5x. Negative 20x divided by 5x gives me negative 4. Okay. So far, so good. Yes, you are. You're doing great. You always have the answers. All right, so x minus 4 doesn't factor, but this guy does, right? So let's go ahead and factor that one. Factors of 2x squared are 2x and x. And then I got to do factors of negative 3. Okay, factors of negative, one's a plus, one's a minus, one's a minus, one's a plus. Okay, and factors of 3, 1, 3, 3, or 1. So we got to set up on how to factor that correctly so outers and inners will give me that x, that 1x. Okay. All right, does anybody have it? I put a 3 here, 2 times 3, way too much. All right, so I got to put the 3 here. I'll give you a hint. Right there. What does the plus or minus go here? Is it plus or minus 3? What do you guys think? Plus or minus 3? Use your microphones, use the chat. Do I put a positive? Is it 2x plus 3 or 2x minus 3? Plus or minus?
Minus.
Let's see. Put a plus there. Check your outers and inners. That's 2x. That's the inners of negative 3x. Ooh, that's negative x when I add them. I wanted positive x. So we guessed, we checked. That's okay. That should be a plus, and this should be a minus sign. So that makes that a negative 2x, a positive 3x, a positive x, which is our middle term. So we guessed, we checked. It was wrong, but just flippy floppy. And now we can move on. Now, from yesterday, we talked about monomials reduce monomials and binomials reduce binomials. I definitely see a binomial, x minus 4, that I can karate chop and get rid of. Okay. I don't see a 2x plus 3. I don't see an x minus 1. But I do see 2 monomials here. I have x and 5x. This can be reduced because they're monomials. Okay. All right, so final answer, I have 5, I have 2x plus 3, and then I have x minus 1. Okay. Now, if you type that in my math lab, you're going to get the answer wrong because you're right, but you're not right. You're close to being right. Okay. Ask yourself, where are these numbers? These numbers are all on the bottom, right? So I got to make sure they're on the bottom. And if everything canceled out, that means only 1 is left on top. So now that's the final answer. I should have 1 over 5 times the quantity, 2x plus 3x minus 1. All right, any questions there, y'all? Again, I'm going to try to get you out early today, but you guys got to help me out. Use your microphones. When I say, hey, let's factor this thing, let's factor it together. Shout it out. Tell me what your answers are. All right, let's try one more multiplication one, and we'll switch over to division here. All right, here we go. We're going to factor. I've got 4x minus 12. I want to factor that. These are both divisible by what? What can I factor out? Use your mic, use your chat, use your fingers. I know Mrs. Williams knows this. I know this. What can we take out here? Destiny, come on. Isabel, help me out. What can we take out of 4x minus 12?
4 and 3.
Yeah, so take a 4 out. So that leaves me with x minus 3. On the bottom, I've got x squared minus 2x minus 3. So I'm going to factor that trinomial. Factors of x squared are x and x. And then factors of negative 3 that add up to negative 2 are negative 3 and positive 1. Okay, so far so good. I'm going to factor this guy here. Okay, the 4x on the bottom doesn't factor. I'm just going to leave it 4x. But x squared minus 1 factors. How do you factor that difference of squares? How do you factor x squared minus 1? Claudia, Michael, Mariana, Riley. Well, how do you factor x squared minus 1? Thanks for your comment, Hunter. Any ideas how do you factor x squared minus 1?
Negative 1 and 1. One would be x and x, and then...
Like that?
Yeah.
Boom. Very good. All right, so we're going to do a little karate chopping. Karate chop, karate chop. I got x minus 3s. Do you guys see anything else we can karate chop?
Or x plus 1.
X plus 1s. Chop them. When the dust settles, I take a look. I got some monomials here too. So the monomials reduce each other. So the 4s can be reduced. And now when I take a look, the only thing I got left is x minus 1 all over x. Okay, final answer. Now, some people will ask, well, can I reduce the x's? And I say, you can't do that. This is a binomial on top. This is a monomial. You can't take monomials and reduce binomials. You reduce this whole thing, x minus 1, or you reduce nothing from it. You take the whole thing or nothing. Okay? All right. So are you going to use this in the real world? You know, I factor every day of my life. Now, are you going to use this in the real world, Hunter? Probably, maybe not. I don't know. Are you going to be asked to do a certain task and learn that task and be able to replicate that task? Yes. So we're at least working on your problem-solving skills. But are you going to factor every day of your life? Maybe not. All right. I am moving on to division, guys. If you can do multiplication, then you can do division, okay? So if I'm doing some division, all right, I have P divided by Q, and that's divided by R over S, okay? Well, have you guys heard of multiply by the reciprocal? Okay. We are going to flip and switch. We're going to do the old flip and switch, okay? So we're going to take R and S and flip and switch this guy. So we're going to flip it around, okay? Or multiply by the reciprocal. Okay, so we're going to go ahead and flip that guy. Now, sometimes when we flip this guy around, flip or switch it around, we're going to factor as we do it. So you might hear me say, hey, flip and factor, and it's always of the second fraction. Okay, so we're going to flip and factor. So let's take a look at example 3. Example 3, I've got 2x over 3x minus 12. So that guy right there can be factored. So I'm going to go ahead and factor out that 3. And that leaves me with x minus 4. And now I'm going to take this, it's divided by, I'm going to go ahead and change that to multiplication. So we're multiplying by the reciprocal. This guy is going up and this guy is going down. Okay? So x squared minus 2x. Okay, I'll circle this one even in pink so you can see what I'm doing. That guy is now on the bottom, and I'm going to factor it as I go. So I take a look, x squared minus 2x, I can take out an x, and that leaves me with x minus 2. This other denominator, this guy right here, I have x squared minus 6x plus 8. That's now going to be my numerator. So if it's on the bottom, now it's on top. So I go ahead and factor that. Factors of x squared are x and x. And then factors of 8 that add up to negative 6. Both of them are negative. And then factors of 8 that add up to 6 are 4 and 2. So I've got x minus 4 and x minus 2. Okay? If you're struggling with factors, see what you already have on the bottom, and that should help you out. All right, so again, I took this guy, I flipped it and factored in the same step. Okay, so it's called multiplying by the reciprocal. You guys have done that before. That's nothing new. So I take a look. Karate chop. What can you see to karate chop? Ethan, what do you see? Riley, what do you see? What can we karate chop here? X minus 4. Boom. What else can we karate chop? Isabel, fantastic. What else do you guys see? X minus 2. Karate chop. And the last thing I see is, again, I got some monomials here. Monomials can reduce monomials. So this x reduces this x. And what I got left is I got 2 over 3. That's it. Final answer. All right. Let's do one more. We'll finish up one more. I got 3b. 3b. I've skipped a few of them for you guys. I don't think we need to go over. And then after we go over 3b, if you want to see more, we got more we can do. Any questions on 3a before we move on? Are we okay? If you can do multiplication, division, very similar. All right. Let's do the last one. I'm taking this fraction, I'm going to factor it. I'm not changing its position. The top is staying on the top, the bottom staying on the bottom. So I take a look, I've got x squared minus y squared. That is a difference of squares. Factors of x squared are x and x. And then factors of negative y squared are plus y and negative y. And that way when we do outers and inners, they're going to cancel. Okay. What about this guy here? I got 2x squared minus 8x. GCF that guy. What's the GCF? What do you guys see? Greg, what do you see? Jimmy, what do you see? Jose, what do you see? What can you take out of 2x squared minus 8x? 2x. Good job. So I take a 2x out, and now that leaves me with x minus 4. Just double check, 2x times x is 2x squared, 2x times negative 4 is negative 8x, so we factor that right. All right. Last but not least, I'm going to take this guy and flip. So I'm flipping this guy. There's nothing I got to factor. So the 2xy doesn't factor, it goes on top now. And x minus y, if you want to, you could write it like this, because x minus y squared is x minus y, x minus y. So you don't have to do that, but that just gives you the idea visually what's going on. Okay? All right, let's start karate chopping. What can we cross out? What do you guys see? What do you see? Lily, what do you see? Michael, what do you see? Hunter, what do you see? What can we karate chop?
Cross out the x minus y.
There we go. X minus y is karate chop.
Then will we cross out the 2x?
Yeah, so these are monomials. Monomials work together. So this 2x reduces this 2x. A lot of people will try to do x plus y and x minus y, but they're not the same, okay? So these are not the same. That means they can't cross them out. So the only thing there's nothing else we can do. I have a y on top. I have an x plus y. And on the bottom, I've got x minus 4. And I've got x minus y. So there's nothing else I can reduce. Okay? So that's pretty much it, ladies and gentlemen.